Thank you. All right, so we're optimizing. Normally in these type of problem, you're going to be given a couple of scenarios. And a lot of these problems are word problems. Questions are word problems, so you will probably have to write the equations. There are 11 questions in the homework. And as you know, all the test questions come from the homework. So if you do the homework questions, you should be fine. But you will normally be given 2 equations. So let's talk about this for a second. So we have what's known as the primary equation. And I think your textbook might refer to this as an objective function. So the primary equation, or the objective function, is a function to be maximized or minimized. This is a function we're going to try to find the maximum value for or the minimum value for. And then we have a secondary equation. And this is secondary equation is normally the restrictions. And the whole purpose of the secondary equation is, like the name suggests, is to place some amount of restriction on the primary equation. In essence, it reduces our equations from 2 equations down to 1. I ran the homework question here. There's no more notes for this, really. So I'm just going to cut and paste a few problems. And we learn this through some examples. All right, so here's number 1 in your homework. I think it's pretty much spelled out what the objective function is. So our objective function is this one. This is what we're maximizing. They actually tell you. And this is our restriction, our constraint. It's telling us that x plus y is equal to 76. Now, once again, this is, as mentioned before, it's normally to place some restriction on the primary function. And the way we do that is we're going to substitute into the primary function. And it's up to us what we want to substitute for. So we know that x plus y is equal to 76. So we could solve for y or for x. Now, if we solve for y, then this is 76 minus x. Does everyone agree with this? All we did was subtract x from both sides. Are we okay with this? Okay, great. So now what are we going to do? We're going to substitute for y into the primary equation. Because what this does, it eliminates one of the variables. Notice in this problem we have 3 variables. We have not learned how to differentiate a problem with 3 variables as yet. That comes later on in chapter 4 or 5. So right now we're getting it back down to 2 variables. So if we substitute, we have q is equal to x and y is 76 minus x. Did I lose anyone? So what we did was we replaced the y in this equation with 76 minus x. Now we could differentiate it here using a product rule, but it's probably easier if we just distribute this out. And then find the derivative. Now, why are we finding the derivative? Does anyone know? What are we trying to do in this problem? Come on, it's on the board. Someone say something. We're trying to maximize it. Thank you, Marta, right? And we know the maximum occurs at the very top or the very bottom where the critical numbers are. Remember that? So if we have a maximum, it's going to be up here, and this number is a critical number. How do we find the critical numbers? So we did this in 3.1, 3.2, 3.4. How do we find
take the derivative?
And after we find the derivative,
set it equal to 0.
Set it equal to 0. Thanks, Jenny. So that's why we're doing this. So this just all ties in back to what we did before. So it's all about the same thing. The whole 4 sections about finding critical numbers and finding maximum and minimum. And the problems just get more complicated. So Q, which is a Q prime, which is a notation, is 76 minus 2x. That's our derivative, which we're going to set equal to 0 and solve. So 76 is equal to 2x, divide both sides by 2. So x is equal to 38. So let's go back up. So we're trying to find a pair of number that maximize a number. So we still haven't finished, right? We only found one number. How do we find the second number? Any ideas? Well, what do we know? We know that x plus y is equal to 76. Yeah, we can plug it in one of the original equation, right? Preferably the second one here because we know what x is, so we could find y. So if we substitute for x, and we subtract that, y is also equal to 38. So surprisingly, both numbers come out to be the same. So the pair of numbers here that would produce the maximum product and add up to 76 is 38 and 38. Yeah. Does that make sense to everyone? What are we looking for? Two numbers that adds up to give us 76 and have a maximum product. Can we think of two numbers and we add them will give us 76? So two numbers when you add will give us 76. Can we think of two numbers that does that? 1 and 75. Do we agree with that? When we add those, do we get 76? All right. Not too difficult. About 2? 2 and 74. 3 and 73. 4 and 72. It goes on forever, right? We have a lot of numbers that when we add will give us 76. But let's look at a product. You guys help me with this, with your calculator. Well, 75 times 1 is 75. What is 74 times 2?
It's 148.
148. And what about 3 times 73?
219.
219. And 4 times 72?
288.
288. What? And do we see what's happening? The product is getting larger, right? So the product here is 288. Until we get to finally 38 and 38. What is 38 times 38?
1,406.
1,406.
6.
So this is a maximum product. 1,444. Which is it?
Samir is right. My bad.
Okay. It's all right. So here we go. This is a maximum product. So we probably could have done this using, just math and write out all the numbers and eventually get to 38 times 38. But just so I just did that to demonstrate what we're talking about. We're thinking about all the numbers that add to 76. And here, this is just positive numbers, right? It could be fractions and decimals. They didn't put a constraint on it. All right, let's try another example. So hopefully no one does this, right? That's not what we're trying to do. That defeats the prop, and you won't be able to do that for much problems anyway. Let's grab a next problem from my math lab. Let's try number 3. This is a 3-part question, so this is the first part. says write the objective function in terms of x. Number 3. So which one of these function is the objective function? And which one is a constraint? Let's make this easier. Let's call them A and B. Which one is our objective?
The constraint function is the x plus y equals 8.
Okay. So that's our constraint. And this is our objective function then, right? Because that's what we're maximizing. So whatever we're maximizing or minimizing, that's our objective function. And the constraint, we're always going to substitute into the objective function. So that's what they're saying. Notice there's a y in the objective function. They do not want the y. They said write the objective function in terms of x. That means we're going to get rid of the y. So not much different from what we just did. So we know that x plus y is equal to 8. We need to find out what y is. So we're going to subtract x from both sides. So y is equal to x minus 8. Now that's what we're going to take and substitute for y. So our objective function is now 6 times x squared plus 2 times x minus 8 squared. Now we probably want to expand this and simplify it. So q is equal to 6x squared plus 2. And if you expand x minus 8, that's x minus 8 times x minus 8. You can FOIL this out. It comes out to be x squared minus 16x plus 64. If we distribute this 2, it becomes 2x squared minus 32x plus 128. We can actually combine the x squared. So now we have 8x squared minus 32x plus 128. This is what part B was asking us. They're asking us the interval of interest for the objective function. Let's just copy this. So basically, what is the domain of this function? And how do we know that? And this was actually the answer for part A. They didn't expand it all the way down. So what is the domain of this function? Does anyone know?
Is it negative infinity to positive infinity?
How do you know that, Jenny?
Because it's going to form a parabola.
It's a parabola, right? I agree with you on this. Right, and we know is it right side up or upside down?
It's right side up.
So it looks like this. So we know it's going from, negative infinity to positive infinity. So that's all this question is asking us. So that's answer for part B. Let me copy over part C. All right, so here's part C. This is where the calculus comes into play. Find the minimum value of Q. How do we find minimum and maximum? Well, anyone?
You're gonna find the critical numbers and then plug it back into the original equation.
And how do we find those critical numbers, Jenny?
You find the derivative.
So we find the derivative. All right, so every time you see those maximum, minimum, we're looking for derivative to find critical numbers, right? And our function is here, so what is that? 8x squared. So our Q is equal to 8x squared minus 32x plus 128. So we're going to find the derivative. So it's Q prime is equal to 16x minus 32. So we're going to set this equal to 0 and solve it. X is equal to 2. So this is the X value that produces the minimum value. We're actually trying to find Q, the minimum value of Q. So what is Q equal to? Q is equal to 6x squared plus 2y squared. We already know, so this is going to be 6 times 2 squared plus 2 times, but we need a value for y. And we can plug that into this equation here. We know that y is equal to x minus 8. So y is equal to x minus 8. So y is equal to 2 minus 8. So y is equal to negative 6. So now we can substitute back here. And what do you guys get for that? Then I want to get a number answer for this.
96.
96. Can anyone else confirm that? Sure, it's right. I just need some confirmation.
She's right.
She's right. All right, let's work on the next problem. Since no one is answering, I'm just going to randomly choose some of you guys. And if you don't answer, I'm just going to mark you absent. How does that work? Sounds good? Sounds like a good tool to me. So everyone will get a chance to answer a question today, and that's going to count as your attendance. All right, next problem. And they only get more challenging, so I suggest you answer as fast as possible. Let me copy this one. This is number 5. All right, so here we go, we're on the beach. So lifeguard need to rope off a rectangle swimming area in front of Long Lake Beach, using 1,700 yards of rope and a float. Number 5. All right, so what dimensions of the rectangle will maximize the area? And what is this maximum area? And note the shoreline is one of the rectangles. All right, so you guys can mentally see this, maybe. So here's our shoreline. You know, we have the water, you know, out here somewhere. We're gonna rope off a rectangle area. So, you know, we have a rectangle area in front of the beach. You know, with some local buoys, some floats on it to keep it afloat. So that's a rectangular area. Now we need to come up with some equations for this, right? So what do we know? It's a word problem. How do we normally do these word problems? Well, we've started already by, you know, drawing a diagram. What else can we do? How about labeling the sides? Let's call the side X. And if it's a rectangle, what is the side over here going to be?
It's also X.
It's also X. Wow, I'm getting a lot of answers. Wow. What happened? Reginald. See. All right, so we got X's here. What do we want to call the next side? What do we want to call the next side? We could call it Y. We could call it anything we like, right? We could call it Z. We could call it A or B. Anything we like. Now here comes the difficult part. Writing the two equations. So how much, what's the length of rope we have? 1,700 feet. So let's write our first equation. What is going to give us the 1,700 feet? How do we get this? What plus what plus what will give us 1,700 feet? Faith. How do you get x squared, Faith? I'm more inclined with Cameron's answer because we're going to add all the sides, right? If you add the x plus the y, we're going to get 1,700. So we have 2x plus y is equal to 1,700. Now, is that our constraint or is that our objective function? No, I did not. I saw you left. I thought you got scared and left, Luis. Okay. So this is our constraint. Only doing tests? Okay. Fair enough. Marta, you said objective. Someone says constraint. All right, how do we know whether or not this is the objective? What are they asking us to find? What are we maximizing?
Y.
We're maximizing the area. Is this a function for the area or is this a function for the perimeter? What we just wrote, is it perimeter or area? It's perimeter, right? So this is a perimeter. It's perimeter when we add all the sides. All right, so what's the area? Because this is what we're trying to find. The area that we're maximizing is here. How do we find the area for that?
You multiply x times y.
So area is equal to, let's call it A, is equal to x times y. Length times width, or in this case, could be base time height. All right, Marta. So Marta, this is going to be our objective function. Are you still confused? I know earlier on you said you were a little confused, like a couple of minutes ago. All right. Do you agree with these two functions at least? Does these two functions make sense to you? One is for area and one is for perimeter. Okay. Now, if we go back to the question, notice it's asking us to maximize the area. Now, if we go back up, all the way up, we were saying earlier on today, the primary equation or the objective function is a function to be maximized or minimized. So the objective function is always to be maximized or minimized. All right, you're confused in how we find area. Well, you just told me that this was a rectangle. Right? And how do you find the area of a rectangle? You tell me baseline height, which in this drawing could be the same thing. Right, so that's our area function here. So this is how we got this first equation. Because the length is y and the width is x. Are you okay with that? And this is the length. So that's our first equation. And it's also our objective equation because they asked us to maximize it. So we know this is an objective function. This is the one we're going to take the derivative of. Now, how do we get the next one? They told us we had 1,700 feet of rope. So if we add this side and this side and this side, so if we had all three sides together, it's going to give us 1,700 because that's all the rope we have. So, you know, once we spread that rope out, we're going to get 1,700 feet. So when you add all the sides together, which is what we did here, so we add one side, which is x. We add the second side, which is x again on the right, and we add the top side, which is y. When we add all three sides, it adds up to 1,700, which is how we got this function. Does that make sense now? Or some more sense? Okay. So that's how we got our two equations. And that was the difficult part. And I understand it's a little more challenging writing your own equations. Now, once we get to this stage, it's doing the same thing we have been doing, right? Or we just previously did. What are we going to do with the secondary equation or the constraint? So this is our constraint. The constraint always gets plugged into this. So we're going to take the 2x plus y is equal to 1,700. I'm actually going to solve for y because to me it's easier. If I solve for x, I'm going to have to divide everything by 2. So y is equal to 1,700 minus 2x. Now that I have a y value, I can replace the y here. So my function now becomes a is equal to x times 1,700 minus 2x. So a is equal to 1,700x minus 2x squared. And since we want to maximize the area, what are we going to do?
Find the derivative.
We're going to find the derivative Samara. I was just about to call in some. Thank you. All right, so we're going to find the derivative. So a prime is equal to 1,700 minus 4x, which we're going to set equal to 0. And so that becomes 1,700 is equal to 4x, or x is equal to, what's that? 425. So now we have our x value, 425. So if we go back up here, we know that the sides is going to be equal to 425. Well, we still need the length, right? Because they ask us what dimensions will maximize the area. So we need the length and the width. Yes, both sides. So how can we find the width, the length? Well, we know that y is equal to 1700 minus 2x. So we can plug that in here. So y is equal to 1700 minus 2 times 425. So y is equal to 1700 minus 850. So that's 850. So y is equal to 850. So the dimensions are 850 and 425. That's the length and width that will maximize the area. They also ask us to find the maximum area. Of course, if we to find a maximum area, that's just going to be 150 times 425. What do we get for that? 36,1250. All right, so let's go back. So this is a multiple part question. The first part was to get the objective function, which is here. This would be like part A. The second part was to find the dimensions. This is the dimension, the length and the width. This is part B. And the third part is to find the maximum area, which is part C. And once again, scenario, yes, this was number 5. We can get in 2 more problems. So many nice problems. All right, so you have about forward profit and loss. We're going to do one of those, but I want to do one more, maybe with a dimensions. Let's do number 6, because you have about 3 or 4 problems. This is hard. Well, look at it this way, Murta. You have 5 days in which to master 11 problems. If you know how to do these problems, it's the same problems on the test, right? I can learn to do 11 problems in 5 days. Even if I don't understand what's going on. That's what I think. But you won't be able to do that if you wait until the last minute. No, some of you are still on 3.1 homework. I do not give extensions or makeup. Believe it or not, everyone in this class has something going on in their life. And so you deal with all these issues that make us different. You can't handle it in class, or you're going to handle it in the real world. School is more than just about the content we learn. All right, here we go. Number 6. So drum tight containers is designing an open top square base rectangular box that will have a volume of 32 cubic inches. What dimensions will minimize the surface area? And what is the minimum surface area? So we know we need 2 formulas in this problem, right? Do we agree? What are the formulas for? But we need formulas for what? Let's read the question a few more times. Yeah, we're going to minimize. What are we minimizing?
The objective function.
So we're minimizing the objective function with the surface area. So this is our first formula we needed. We need a formula for a surface area. All right, what else do we need a formula for?
The volume.
For our volume, very good. So we need a formula for this. And we need a formula for volume. These are the 2 things I mentioned. Come on, eraser. It's kind of difficult to visualize. So what can we do? Maybe we can do what? Maybe we can sketch it like we did the last one, right? So we're gonna, what are we doing? A box. An open top box. So, and it has a square base. So we have a box that has a base that is square. We know what it means by it to be squared, right? What are some of the conditions of something being squared? All sides are equal, I agree. So let's say we call this side x. What is the next side going to be? X and x and x and x, right? So all sides are x. All right, so this is just the base. Now let's build our box. So we're gonna go up, you know, that's a box. We go up. So we're building our box. There we go. So this is our box. How many sides does this box have? Close.
Yeah, it's 5.
It's 5, right? It would have 6 fate except what? Why does not have 6? Open top, right? The top is open, so that doesn't count. So we have the 4 sides and the bottom. Are we okay with that, Myrta? That's how we get 5. All right, let's give this box some height. What do we want to call the height? Maybe y. Very good. All right, now we have enough information to write our equations. All right, let's start with the volume. You guys know how to find volume of a box? It's the area of the base times the height. So no, we know the height is y. And what's the area of the base? How do we find it? The base is a square, right? How do we find the area of the base? How do we find the area of a square?
X times Y.
The base, that's the base. We're trying to find the area of this little piece down here. The bottom, the base.
X squared.
X squared, because it's x times x, right? It's a length times the width. The formula for finding an area of a square is the same thing as a length times width. It's still a rectangle, it's just that all sides are equal. So this is x times x for the base. So the volume for the rectangle is actually x squared y. Do we agree with that? And they told us a value for the so we know the value for that is 32. So this is our constraint. Because we know we're minimizing the area. So let's find the area. All right, let's start with the base. What's the area of the base?
X squared.
X squared. I'm looking for someone to pick on. X squared. We just said that, right? How about one of the side of the box? One of the side of, let's say this. What is the area of this region in green? One side doesn't give us an area. How the side is a rectangle. How do we find the area of that?
X times Y.
X times y, because the bottom is this, is x, right, and the height. So this is a rectangle right here. We're trying to find the area of. It's x times y. Now, how many of those sides do we have?
Yeah, 4.
We have 4 of those. So we have 4xy as the area of the sides, plus the bottom. So that's our area. So our area is actually equal to x squared plus 4xy. Now let's go back. We're going to plug the constraint into this. So what do we want to solve for? I probably want to solve for y. So we have 32 is equal to x squared y. So y is equal to 32 divided by x squared. We're going to take this and plug in for the y. So a is equal to x squared plus 4x times 32 over x squared. So once again, the difficult part, writing the equation. Here's just algebra. We solve the constraint for one variable and plug it into the objective function. So I have a is equal to x squared plus 4 times 32, that's be 128. And this becomes over x, because one of the x's will cancel out. So this will cancel one of the x on the bottom. So this becomes a is equal to x squared plus 128x to the negative 1. And we want to write as x to the negative 1 because we're going to take the derivative. So a prime is equal to 2x minus 128 x to the negative 2. We're going to set that equal to 0 and solve it. So 2x minus 128 x to the negative 2 is equal to 0. Or 2x is equal to 128x squared x to the negative 2, my bad. 2x is equal to 128 over x squared. We're going to do the cross product here, just more algebra. So we're going to multiply this by this. So we get 2x cubed is equal to 128. Divide both sides by 2. X cubed is equal to 64. Take the cube root of both sides, and we get x is equal to 4. Oof. All of that. So now that we know that x is equal to 4, let's go back up to the question. What dimensions will maximize the surface area? So we're trying to find the dimension. So we're trying to find the length and the width. So we need to find y also. We know y is equal to 32 over x squared. So we know y is going to be equal to 32 over 4 squared. So y is equal to 32 over 16. So y is equal to 2. So these are the dimensions. The height of the box is a very short box. So my drawing does not do this justice. My drawing is on the high side. This looks more like a shoebox kind of thing, a very low. Now, what is the minimum surface area? Well, we need to go back to the surface area formula, which is this. And plug in for x and y. So that's x squared plus 4xy and we're going to substitute. So that's 4 squared plus 4 times 4 times 2, 16 plus 32, just 48. So the surface area is 48 inches or whatever units they were using. And it was in inches now that I look at it. All right, so and before Samir asks me, $3.6, this is number 8. Samira,
Yes.
are you gonna have time for what?
I was saying because you said the test is due Monday, but
Yeah.
are we gonna have time to do 5 and 3.6 on Monday in order to get to the test, and we have to finish the 3.6 homework before the test, and then practice?
Hold on, I don't understand what you mean by 3.5 and 3.6 homework.
Because we're doing 3.5 today, right?
Yeah.
Are we gonna have time to finish it today, 3.5?
Yeah, we're done. We're just doing this one question, we're done. We're not doing 3.6 is not on the test. 3.6 is on the next test, test 4.
Oh, okay. Okay, never mind.
Yeah, 3.6 is test 4.
Oh, okay. So are we gonna have class Monday or no?
We are having class on Monday.
Okay. All right.
I'm going to take attendance from the chat box. Whoever replied in the chat box, that's my attendance. I thought I mentioned that, right? So if no one replies, then they're here. They're just logging in.
So what if I just use my microphone?
Jenny, you're here all the time.
Okay.
All right, find the maximum profit and the number of units sold. So we're going to find maximum profit and the number of units sold that must be produced and sold in order to yield a maximum profit. Well, they gave us, I must have not copied something. They gave us the functions. If you guys have questions, don't forget, you can always email me. And please email me in Blackboard Faith. I do not use the email inside of Banterweb. We've established this from the beginning of semester. All right, so how do we find a maximum profit? The good news is they gave us the functions here, right? How do we find profit? That's the only thing we need to find. What's the function for profit? You sure? If you add your revenue and your cost, you're going to get profit? What is profit? Come on. I talked about this not too long ago. Profit is revenue minus cost. You make a profit, right? You have to take away the cost from the revenues. You can't add your cost and revenue to get profit. All right, so here we go. So P of X. Look, you have a lot of questions about profit and loss throughout the semester. So this is it. So it's 60x minus 0.5 x squared minus 6x minus 20. So that becomes 54x, because we're subtracting the 6x, minus 0.5 x squared minus 20. So this is a profit function. Not much work required here. They gave us the two objective functions, constraints already. So all we had to do was plug them into each other to get the profit function. We're trying to find maximum profit, so we're going to take the derivative. So that will be 54 minus 1x. So we have 54 minus 1x is equal to 0. So 54 is equal to x. Yeah, so you figured out we got rid of the 6, we combined the 60 and the 6 to give us 54. All right, so x is equal to 54. So that's the number of units that must be produced and sold in order to produce the maximum profit. So that was the number of units. So what else did they ask us? Find us the maximum profit. Well, how do we find the maximum profit? We plug this in, right? Because that's a profit function. So we have, so we're doing P of 54. So this would be 54 times 54 minus 0.5 times 54 squared minus 20. So if you're here, now is the time to type here in the chat box so you can get counted for attendance.
1438.
1438. So once you type in your name for here, we're done for today. So make a profit of $1,430 for producing 54 units. All right. Do you guys have any questions on this? Let me know. I'm still recording the chat, so if you haven't put in your name, go ahead. If I stop recording, then you will be absent. All right, any questions before we go? No. And if you do have questions, I'm here, every day. Friday, Saturday, Sunday, Monday. It doesn't matter to me. I spend a lot of time around my computer. All right, Faith, please text me, email me right here in Blackboard, and I'll get back to you. I don't hear from you guys. You guys have a great weekend. Don't forget, quiz is due today, and test is due on Monday. We are also meeting on Monday. All right. Bye. I'm going to cut off recording.